Very good.
I think on
That
the
was really short.
Which office is that?
I don't know. David.
Well,
We never really figured out what that because we have no place that's like many other bridges. They have a small number of ice.
Thank you.
Florida's Turnpike, check it in.
District 5, checking in.
No. 496.
Okay, I'm from Advanced Engineering Solutions. We are a geofoam design company. That's all we do is design with geofoam. Now first off, I want to tell you that this is an open type forum. I want you guys to be able to ask questions if you have it. Just stop me because this is your time to learn some more about geofoam. If you wait to the end, you might forget the question that you have. We're here to give you as much information as we possibly can in the time that we're allotted. Now, also, I'm an engineer. There we go. Your experience that you've had with EPS, or the term is expanded polystyrene, but used in roadway applications, they use the term geofoam. Exactly the same thing. Okay, one of the other things that was really interesting, and no offense, this is just what they did, is I put in here innovation of young minds, because on the task force, they would not allow an engineer over the age of 40. ACT does, is ACT goes around and guides the contractors how to install. Right now, let's see, we have a little over 275 EPS fields that we've been involved with. Those fields have ranged anywhere from Canada to Panama, parts of the Middle East, parts of Africa, Europe, and Australia. And what I want to do is I want to teach you just a little bit about geofoam. This is the first geofoam project. Geofoam has been around since the late blocks in 1972, and you can see that the settlement has calmed down. Now, one of the differently is I would have put more. The United States was really only 10% or so. Right now, the way it sits, the United States is probably about 65, 70% of the world market now. So it's really grown exponentially. And this is what's happened. In 1997, we used EPS in the Salt Lake City project. That was the largest geofoam project in the world. This was only 70,000 cubic meters. That was 120,000 cubic meters. And that kicked it off because FHWA was involved in it. They then got their feet wet, and right now, you can see this article that's here by Silas Nichols. They're a very strong proponent of it. They're very happy with the way it's been performed. Now, there's a lot of different areas that you need to be aware of with the EPS discipline. Design considerations. Now, normal load reduction, geofoam, I have to tell you, is usually the last resort. It's there's nothing else that works. Let's throw geofoam into it. Weight comparisons. These are just your weight comparisons. Regular backfill is 120 to 130, 135 pounds. Depends on where you get it. Highly combustible after a period of time. But EPS, look at that, 1 to 3 pounds per cubic foot. This is what it looks like. This baggie of soil weighs exactly the same as this block. So it's a true replacement of weight. This is a term that we use in geofoam design. It's called zero net loading. Now let me explain to you a little bit about this when you're done. One of the aspects about buoyancy, the Corps of Engineers, state of Louisiana, is now reviewing EPS as an alternative for the dikes replacement. They have an issue with their dikes that they have to raise those dikes 30 to 60 feet. Any additional soil they place on those dikes are just going to settle more and just cause more problems. And so they're actually looking into the EPS. Environmental has exactly the same thing. The life expectancy of an EPS in the project is over 100 years. It doesn't change. It's an inert material. It does not leach any hazardous material to it. The only thing that can cause problems with it is going to be petroleum products. And we'll touch a little bit through the presentation on petroleum products. This is a petroleum-based product. Slides just coming up here shortly now. That's the only difference with EPS is you've got to start placing your utilities in the beginning of the fills when you start building the fills for the 5-inch pipe that goes through the fill. It's very easy to cut these extra. Low distribution slab. And this is very, okay, let's talk just a little bit about the theories going across the United States. Steps that are built in or cut in, and now it's ready to place the steel. This is the steel reinforcement that is being placed for the low distribution. This is a closer look at it. This is actually what they've done is they've poured part of the low distribution slab and now they've got the steel reinforcement. So here's a step, wall panels. This is the next. Tie our wall panels in directly to the low distribution slab. This is what the panels look like after being set. You can see the EPS fill, you can see the gap between the low distribution slab. They've tied the pins in for the wall panels and they're getting ready to just do the closure. And this is what the panels look like at the end. These are actually 2 culvert crossings. They're 3-foot culverts. And then that brings us down to the grade beam. Now on the shorter abutments. Construction techniques. This is transportation. Interesting thing about I-15 is in placement. Now it was interesting on this particular picture.
How much is one of those blocks weigh?
You figure 6 yards. Now there's 2 types of testing. The first type is laboratory. When you test in a lot of, in UK, types of EPS projects. Now here are 12 because they still had their concrete deck they had a sensitive area where they could not place. See here that they're that 2x4 and popped power line. This EPS cost in the neighborhood of $60,000. So there's a big trade-off between using the EPS versus the utility. Here's another picture. We have a soil stabilization ways that those utilities. There's a lot of movement right now in placing EPS directly underneath buildings. Placing a landscaping fill directly on top of a 5-story apartment. How many questions?